So earlier this week, I took a look at the ability to use an order by and a limit clause within an update statement in MySQL. And in that post, I said that such a technique can be used to run a migration. And because this is a technique that I've used with pretty good success in the past, I thought it'd be interesting to flesh out a larger demo. So to showcase, I've created this migration task database table. And the idea is that this task represents a finite set of work. In this case, it has 50,000 records in it. And the unit of work for each record is going to be to pull down this image URL and process it. For the sake of the demo, I'm just going to download it. I'm not going to actually do any additional processing because that's not really the point. But essentially, what I want to do is be able to traverse this table using multiple parallel workers, in this case on the same development server, but in production perhaps across many servers. And then each one of those workers would iterate, look for open records, status open, and then claim those records, process them, and then mark them as completed. And I want to do this in a way that they don't step on each other's toes, they're not processing the same records, and we're also not crushing the database. So let's take a look at how this works. To set up a simulation of multiple workers, I'm on a single development server. So what I'm going to do is use iframes here, and each iframe is going to represent a particular worker, and then I have another iframe at the top here that represents the controls. The controls give us the ability to start and stop the migration. Let's look at those controls quickly. What we'll see is that I have this application is processing flag, and that's going to be used to drive the workers. Now, because I'm demonstrating this on a single server, I can use the shared application scope. However, in a production multi-server environment, you need to move this flag to an external system like Redis or perhaps a LaunchDarkly feature flag. But what you'll see is essentially I just can either stop the processing, turning it to false, or start the processing, turning it to true. And if I'm going to turn on the processing, I just reach into the parent window and I reload all of those iframes. So here in my frame set, if within the control I start the processing, essentially what I do is I reach up into these workers and I just reload them so that they'll start kicking off the workers. I tried to have 10 workers, which I was able to do with, I was able to kick it off. I just wasn't able to stop it because I think the browser wasn't letting me make additional pending requests to the same domain. So in order to actually demonstrate the stopping and starting, I'm limiting it to 3 workers. Now, the whole point of this is to look at how the worker is operating against this shared data table in a way that doesn't, again, step on each other's toes and also doesn't crush the database. So if we jump over into the worker, I've tried to separate out the algorithm of the worker from the implementation of the individual steps. So what we can see is that the worker is essentially going to continue looping while that global flag, that is processing flag, is turned on, right? Because we need to be able to turn it off as needed. And then at the top of each iteration, we're going to reset overdue tasks. So in a production environment with a migration, you have to assume that something is going to go wrong. Trust me, it almost always does. So not only do you need a way to stop processing, you need a way to reset tasks or pull tasks out of rotation. In this case, for the simplicity of the demo, I'm just going to reset tasks that have been pending for more than 2 minutes. Then each worker gets a unique ID, and I claim the next set of tasks. Now this method here, this is where that order by, limit, and update combination is going to come into play. Essentially, this is going to grab the next 10 pending next 10 pending tasks from the database table, then loop over each task, process it. If it processes successfully, mark it as complete. Otherwise, if there's an error, we're going to log the error because, again, you have to assume that something is going to go wrong in migration, whether it's an invalid configuration value, an upstream service that crashes, an upstream service that starts throwing rate limiting errors, all kinds of stuff, disk errors, network errors, so on and so forth. If there is an error, then I'm going to reset that task, which just means I'm going to return it to the pool of open tasks. So let's look at this claim next block of tasks, because again, this is where the real magic of this post is coming into play. So if we jump down, what's going to happen is first this worker is going to claim records on that migration task table, and this is where the update, order by, and limit combination comes into play. So what we're doing is looking for open tasks and then we're going to order by ID, limit to the particular limit. In this case, it's going to be 10. And what you can see is that I'm setting those records to be claimed by this particular worker. So because I can only set the claimed by where the status is open, and I'm changing the status to processing as part of the claim, what it means is that this particular worker will be able to claim a unique set of records even while other workers are also attempting to claim records, because none of them will be able to satisfy both the open and the changing to process on the same record at the same time. That's the magic of the database itself. It's doing that wonderful work for us. Now, in this case, I'm breaking this claim query from the return query apart because I want to look at the actual execution time of the claim to see how it operates under load. But ultimately what happens is after I've claimed my records, I then pull back all of the migration records that have been claimed by this worker and are now in a processing state. I'm going to return those. So those are, right, those are the tasks that I'm pulling back here, and then I'm looping over and processing them. And then completing it just changes the status, and resetting changes the status back to open. But let's go ahead and take a look at how this is working. So if we pull up our demo page and we pull up our terminal, so again, this is an iframe up here. This represents the starting and stopping. These are our 3 iframe workers. And now what happens if we start processing, you can see that I'm resetting and I'm claiming and I'm downloading images in the background. And actually, you know what, let's stop this and let's jump in here and let's change this from 10 down to 1 just so we get a little bit more activity. So now let's pull up the terminal again, start it, and you can see each one of these workers is now claiming and then trying to reset outdated methods. There's 50,000 records in this table. There's 3 workers simultaneously trying to access it. We can stop it at any time. And again, when you perform a migration in production, you have to assume that something is going to go wrong. Something unexpected is going to happen. There's going to be dirty data. There's going to be unexpected state. There's going to be things breaking in ways that you didn't account for. There's going to be edge cases that you didn't realize were happening based on production data. You need a way to stop and start migrations. You need a way to monitor the state of the migration. You need a way to look at errors that are being produced by the migration in order to make educated decisions about how you need to move forward. And in this case, again, we have the stop and start. We have our terminal output. You can see that multiple workers are concurrently hitting the database, claiming records using that update plus order by plus limit feature of MySQL, using that to isolate records for processing them individually, and then setting those records to being processed. And there we go. You know, this has 50,000 records in it with 3 workers. You can see the performance is really good. When I had 10 workers running, the performance was pretty much exactly the same. The claim times kind of varied between 70 milliseconds and like 300 milliseconds. I don't know if this would scale to billions and trillions of records. Probably not. I think, you know, you're starting to deal with a different level of system there. But in the Cold Fusion and MySQL applications that I've built in the past, I've used this type of approach with pretty good success, and you know, I find it to be the pragmatic choice. We didn't have to pull in additional technologies like RabbitMQ or Amazon SQS. We were able to do it with the technologies that we already had in the application, reducing the level of complexity. I mean, you can see the code for this worker. I mean, it's pretty simple, right? There's a couple of steps, and each one of these steps is more or less just a SQL statement. This is the actual process, and you can see for the processing, I'm just downloading the file, completing the task, again, just changing the status, resetting the task, again, just changing the status. In reality, you know, you might want to isolate a record if it fails multiple times, because you may need to investigate why that particular thing is failing. You don't want to become a so-called poisoned pill within the migration process, continually tripping up workers. But again, for the simplicity of this demo, really what I wanted to showcase here was the update plus order by plus limit as a way to have multiple concurrent workers hit the same migration task table safely and efficiently. And hopefully this illustrated the point.